Hello everyone, this is Jala Babu. My roll number is 25B25A 0408 from ECE department in University College. Today we will talk about autocorrelation process. Autocorrelation process and overview concepts and steps. What is autocorrelation? Autocorrelation refers to the relationship between a time series and its own past values. It measures how much the current value of a variable is influenced by its past values and collect time series data by lags. Calculate correlation. Repeat for multiple lags. Plot ACF. ACF means autocorrelation function. Interrupts results. Autocorrelation is one of the most fundamental concepts in signal processing and statistics, communications theory, and time series analysis. It provides a detailed understanding of, how a signal relate to itself over different time shifts. Uh, the term autocorrelation literally means self-correlation. That is, the correlation of the signal with a delayed or shifted version itself, and it measures the degree of similarity between the original signal and its time shifted contract. Autocorrelation reveals important characteristics of signal such as a periodicity and energy distribution, randomness, and repetitive patterns, making it an essential total in analyzing natural and man-made signals. Purpose of autocorrelation. Identify repeating patterns, detecting sensation in data, analyzing series structure, and forecasting future values, and detecting patterns and trends, understanding sensitivity, noise, filtering, and signals, machine learning time series analysis. These is the types of purpose of autocorrelation. Consider any time varying signal such as speech, ECG, and sound waves or voltage waveforms. These signals often contain patterns or repeated structure. By shifting the signal in time and comparing it with itself, one can determine whether such pattern exists. The comparison is done mathematically using autocorrelation. The signal has a strong similarly after a certain time delay. The autocorrelation will show a high value at that delay, indicating periodicity or repetitive nature. The signal is a random with no repeating pattern. The autocorrelation will be close to zero for all delays other than zero. Mathematically definition, R of k equal to 1 by n minus k convolution summation of x of t convolution x of t minus k, where k equal to lag. The autocorrelation mathematical definition is a two types. One is continuous time autocorrelation and a discrete time autocorrelation. For continuous time signal x of t, the autocorrelation function is defined as a r x of tau equal to minus infinity to infinity x of t into x of t plus tau into dt. Here, rxx of t tau is the autocorrelation function. Tau is the time shift of or delay. Time and the integral measures the similarity between x of t and x of t minus t plus tau, where t equal to 0. The autocorrelation gives the total energy of the signal. Suppose Rxx of 0 equal to minus infinity to infinity x square of t into dt. For discrete time autocorrelation, For discrete time signal x of n, Rxx of k equal to summation n equal to minus infinity infinity x of n into x of n plus k, where k is an integer representing the lag, and Rxx of k is the discrete autocorrelation sequence. Steps in autocorrelation. Choose lag values, shift data by lag, multiple paired values, sum and normalize, compute correlation, and collect time series data. Physical and intuitive meaning. Autocorrelation essential answer the questions. How does the signal behave relative to itself at different times delays? When the signal is shifted slightly and suppose small of t, the overlapping portions may still resemble the original signal, give high autocorrelation. When the shift is large, the signal may no longer match itself, giving low autocorrelation. If the signal is periodic, the autocorrelation exhibits peaks at multiplies the period. Autocorrelation produces a function where positive values indicates similarity, negative values indicates an inverse relationship. Zero values indicates no similarly. Uh, Example of autocorrelation. Example 1. Weather temperature. If today's temperature is high, tomorrow temperature is likely to being high. This means positive autocorrelation. Example 2. Stock price. Stock price often show trends. If the price was rising yesterday, it may rise today. This is positive autocorrelation. But if a stock is violet and shows opposite movement, has a negative autocorrelation. Interpreting autocorrelation is three types: high positive value to strong relationship. Now, near zero to weak relationship. Negative value to inverse relationship. Properties of autocorrelation. Autocorrelation has a several important mathematical properties. Maximum at zero lag. Rxx of 0 greater than equal to Rxx of tau. Second one is even symmetry. Rxx of tau equal to Rxx of minus tau. Periodicity preservation. If x of t is a periodic with period t, then Rxx of tau equal to Rxx of t plus mt. The autocorrelation of a periodic signals is also periodic with the same period. Energy relation. Fourth one is energy relation. For energy signals, Rx of 0 equal to integral minus infinity to infinity mod x of t whole square dt. For power signals, Rx of 0 equal to p equal to limit t tends to infinity 1 by t minus t by minus t to t mod x of t whole square dt. Fifth one is autocorrelation of white noise. R omega of tau equal to n0 del of t. That is maximum only at zero lag, almost zero elsewhere. This shows that white noise has no correlation with itself any delay. Sixth one is relationship with power spectrum. The Fourier transform of the autocorrelation function gives the power spectral density. This is the PSD. Sxx of f equal to Fourier transform of Rxx of tau. This is known as the Wiener-Kinch theorem. Linking to the time domain similarly with the frequency domain energy distribution. Autocorrelational plot ACF. ACF is visualize autocorrelation for multiple lags. Applications. Time series forecasting used in ARIMA models. Detects seasonality and lag relationship. Financial markets identifies trends and momentum in stock price movements. Help detect market insufficiency. Weather, weather prediction analyzes daily sensational temperature patterns and helps forecast long-term climate cycles. Fourth one is signal processing. Detects repeating signals, identifies noise versus meaningful periodic signals. Conclusion. Autocorrelation helps identify patterns and structure in time series data. Thank you.